Hi everyone, now we are at multivariable calculus lecture number 2. So this is continuation to last lecture, problem number 4. Three problems I did in the last lecture. Now continuation problem number 4. Find the limit of 2xy upon x square plus y square as x comma y tends to 0 comma 0. So this one, so in this there are two ways. First one is while substituting the limit, if you are getting 0 by 0 or infinity by infinity form, you're having two techniques. One is simplify the function. Okay, simplify. This is particularly for two variable functions only. Simplify the function. Okay, then we can apply. Or again, if you're getting 0 by 0 or infinity by infinity form, then apply the path limits. Apply the path limits. Okay. So already this technique I did in the last class. Problem number 3 I have done by simplifying the function like x square minus xy by divided by root x minus root y. So remember x square minus x into y divided by root x minus root y. This problem I simplified. Then I applied limit, because if you apply directly limit x comma y tends to origin, this is reaching to origin. If you substitute direct origin here, you will get 0 by 0 form. So this form you are getting. Then go to any one of this. I got this one. Simplify the function. I simplified this. Then I applied the limit. I got perfectly answer 0. So any of these two techniques you can apply. Now look at this one. This is also same kind of it. X comma y reaching to origin. Okay. 2xy upon x square plus y square. If you apply direct limit, what will get? 2 into 0 into 0. So 0 divided by 0 square plus 0 square is 0. So you are getting 0 by 0 form. So here it means x is reaching to 0 and y is reaching to 0. It means, okay, first coordinate tends to here first coordinate, and here first coordinate tends to here first coordinate, like that. So togetherly the doublet x comma y is reaching to the doublet origin 0 comma 0. Now you're getting 0 by 0 form. Then move on to the any one of this technique. First simplify the function. Can I simplify it? Look at, there are no similar terms to cancel out in the numerator and denominator. It's so path limits. So before entering into this, we need to understand carefully. Now function is given to us. Now 0 comma 0 reaching to 0 comma 0. Then this is the point. So this is origin 0 comma 0. This is 0 comma 0. Now in this, let us construct a disk of some radius. Okay. Now what is my goal? I have to reach to this origin 0 comma 0. You can reach along this axis. Okay, that means positive x-axis, or you can reach via negative x-axis. You can reach via this y-axis. You can reach this along this negative y-axis, or you can reach along y is equal to x path, because y is equal to x, if you choose 0 is equal to 0 satisfied. Look at this point need to be satisfied. If I substitute x is 0, y should be 0, like that. Then only this point will be reached along this path only. If I choose y is equal to x plus 1, for example, if I substitute x is equal to 0, if x is 0, then what is y value? Y value is 1. Now you are getting 0 comma 1. So 0 comma 0, this path y is equal to x plus 1, this path cannot reach to origin. It will reach to 0 comma 1. Indirectly, origin does not lie on this path. Okay. Then how this path reach to origin? It cannot travel, right? Only this path can travel to 0 comma 0. The path need to be traveled to that point compulsory. That you should take care. Okay. So here this path cannot travel to origin. That's why I'm not choosing this path. So this kind of paths you have to choose, like this one. Or I can choose like this. Or I can choose this path, y is equal to minus x path. Or I can choose like this. Or it can be travel like this. Any of the path like this. Okay. Or you can choose like this, x is equal to r cos theta. Okay. And y is equal to r sin theta. Okay. Now in this, now if I see, since it is a circle, right? It is a disk. So for this circle, So these are the parametric equation. If I write, for example, if it is a 2 radius circle, x square plus y square, let us say it is a unit radius circle. Then if I substitute x is equal to, so r is 1, right? Radius is 1 now. So x is equal to cos theta, y is equal to sin theta. Substitute cos square theta plus sin square theta is equal to 1, satisfying 1 is equal to 1. Therefore, these two becomes an equations of a circle. That's why I'm taking these two, nothing else. Okay. And as r tends to 0, you have to take. What is r? R is a radius. Okay. So if r is a radius, for example, look at this. So if r is a radiuses keep on reaching to 0. That means radius, for example, I'm starting with the 3 units. R is 3. Okay. Next r is equal to 2. Next r is equal to 1. Next r is equal to 0. That means what? First 3 units radius I'm taking. Okay. That means the big one. Next I'm taking 2 radius. Next I'm taking 1 radius. This one. Next 0 means what? It is shrinking. The circles keep on shrinking because you are reducing the radius. So means if you reduce the radius, the circle keep on tends to origin only, right? It will shrink. The circle will shrink. Obviously, it will reach to origin only. So this is origin 0, 0 because for this circle, what is center? Center is 0, 0 only. Yes or no? So now if you take radiuses keep on tends to 0, the circle is shrinking to 0. That what I want actually. X, y reaching to origin is nothing but r is tends to 0. You can take this kind of limits also. Now r is reaching to 0, you can take. If x, y tending to origin. So this is the ideology for this second method, applying the path limits. Now let us go for first method. Okay, method number 1. So first method. First method. So limit x comma y reaching to origin 2xy upon x square plus y square. Okay, x square plus y square. So clearly if you apply directly limits, you will get 0 by 0. That's what I'm moving to path limits. So now I need to choose a proper path such that along that path, at that path reached with travel to origin 0, 0. Now I am choosing, yeah, look at it. Limit x comma y. This path is reaching to origin along the path y is equal to x. I am choosing along the path y is equal to x, or simply along y is equal to x you write, no problem. Okay, let me write along y is equal to x. Okay, so now this will be, so 2, yeah, 2x, but what is y value? Y value is x again. I am replacing, nothing else. Instead of y I am writing x. Why I am choosing this path again? Since this point is lying on this line, so definitely this line goes to this origin 0, 0. That's why along this path I am finding the limit. Okay, now x square plus again x square, right? Next this will be limit x comma y reaching to origin along y is equal to x path, right? Now this is 2x square, so 2 is 2x square divided by 2x square. Now what do you get? If you simplify this, you will get 1, right? So therefore limit x comma y reaching to origin along y is equal to x. Okay, 1. Now what is the answer? Limit value is, there is no x and y, therefore answer is 1. Now what is the conclusion? Actually you need to choose two different paths. Along two different paths, if you are getting two different limits, then what I can say, so therefore limit does not exist, I can say. So therefore one path is over y is equal to x. Now I can choose limit x comma y reaching to origin. It's like, for example, a sequence minus 1 whole to the power of n. Find the limit of this sequence. Directly limit does not exist, therefore What we have done, we found the subsequences, two subsequences, minus 1 whole to the power of 2n minus 1 whole to the power of 2n plus 1. These two subsequences we calculated. If both are converging to same limit, then original sequence also converges to the same limit L. Same ideology here. So two paths you have to take. Along this path the limit, and along this second path I am choosing, or 2x you can choose, no problem. Y is equal to 2x. Previously y is equal to x, now it is y is equal to x. And again 0 comma 0 lies on this line. So this line again goes to origin. So this is the second path. Okay. Now what is this 2xy upon x square y square. And now this is, so limit x comma y going to origin along y is equal to 2x. Okay. Now this is 2x into 2x. Instead of y I am substituting 2x. X square by 2x whole square. Right. And this will be limit x comma y reaching to origin along y is equal to 2x. Y is equal to 2x will be 4x square divided by, and this 4x square plus x square 5x square, isn't it? Yeah. Now these two will be cancelled out. So if you apply the limit directly I am writing, so answer is 4 by 5. Look at, we are getting two different limits. So this is 1, so this is 2. Okay. So therefore conclusion, from 1 and 2, from 1 and 2 along two different paths, we have two different limits. Okay, two different limits. So therefore limit does not exist. Limit does not exist. So this is the final comment, limit does not exist for this problem. So this is the first method. And same thing you can do like this also. Second method. So instead of choosing separately two parts, you can choose like this. X comma y reaching to origin, right, along y is equal to mx I am taking now. Now m can be anything, any slope now. So what are the line? Y is equal to 2x, y is equal to 3x, y is equal to 4x, y is equal to 5x. In previous first method also here, what I have chosen the second path is y is equal to 2x I have chosen here. You can choose y is equal to 3x also. The only thing is origin should lie on that path. That's it. Y is equal to 5x you can take. Y is equal to minus x also you can take. If you substitute x is 0, y is 0, it will satisfy. Whatever, but that the point should lie on that. The path should reach to that point origin 0 comma 0. Then such a kind of path only I need to take, because I need to go to origin x comma y is reaching to 0 comma 0. Such kind of path only I need to choose. Okay. So instead of choosing these different paths, directly I am choosing y is equal to mx. Now m is any slope. Okay. Now this is directly, no need to choose two times different paths. Directly you can obtain here. Okay. Now what is this? So limit x comma y reaching to origin. X comma y is reaching to origin. Okay. Along y is equal to mx. Now substitute here y is equal to mx. So 2x into y is equal to mx divided by x square plus y is equal to mx. So mx whole square. Okay. Now in the next step, so limit x comma y is reaching to origin, right? It is reaching to origin along the path y is equal to mx. Along y is equal to mx. Yeah. So 2x square m divided by denominator I am taking x square is out. So 1 plus m square I am taking. Okay. Now this x square and x square is out. Now what will remain? So what will get? Limit x comma y reaching to origin. So there is no x and y term. So directly answer is 2m by 1 plus m square. That's it. So now this limit is depending on m. If I change m, for example, if I take 2x, here limit value will change. If I take 3x, limit value will change. So if we change the parts, limit value also changing. So therefore conclusion is here. So therefore limit value is depending on m. So limit does not exist. Limit does not exist. If you want more elaborately this one, that is if we change the parts for different values of m, then different limits we will get. Different limits we will get. Okay, so because of this, y is equal to mx is a collection of parts. In this I am choosing m is equal to 1. M is equal to 1 means I will get y is equal to x. Right? So therefore, along y is equal to x, limit value. What is limit value? That means m is equal to 1 you substitute here in this. M is equal to 1 means 2 by 1 plus 1 square. Answer is how much? 1 only. That's what I got just now by method number 1. Next, let us choose m is 2. So m is 2, you can choose m is equal to 2. That means what? Y is equal to 2x. So this is second part. So again, along y is equal to 2x, limit value is substitute m is 2 in this. 2 into 2, 4. So 2 into 2, 4 divided by 1 plus 2 square, 5. So what is the answer? 4 by 5. Isn't it? So again look at, so from this, let us take this is L1 and this is L2. So since L1 is not equals to L2, therefore limit does not exist. Limit does not exist. So this is more elaborately. Okay. So we can prove like this also. So therefore along two different parts we are having two different limits, therefore limit does not exist. So you can take like this y is equal to mx, like this you can choose some set of parts. If you are getting the limit value in terms of m's, then limit does not exist. If you are getting here 0, for example, if you are getting 0, then whatever m you choose, you are getting 0. Therefore along any two different parts the limit value is 0, therefore limit exists, because limit is same. If you are getting 0 here, if you are getting 0, then limit exists. Otherwise, if you are getting function of m, then limit does not exist. Okay. Next one, by third method, same problem. So you can attack any of these method your wish. Third method number 3, same problem, how to proceed. Okay. So now here, so limit x comma y is reaching to origin. The only thing is here parts. So you are choosing different parts. That's it, nothing else. Okay. So 2 into xy, 2xy divided by x square plus y square. Okay. Now look at here, for the same problem. Now I am choosing the parts, this path I am choosing. Along y axis I am reaching. Let us take like this I am reaching. Next second path I am choosing y axis. First path is x axis. second path is y-axis. So two paths. So this is first path, this is second path. Let us choose this one. So therefore same problem is modifies like this. So limit x comma y is reaching to origin along x-axis. So 2xy upon x square plus y square. Now this is, so limit x comma y, right, reaching to origin along x-axis. Along x-axis means now your path is x-axis. Now any of the point on x-axis will be it look like x comma 0, right? Any point on x-axis, because y coordinate is absent. So therefore here y coordinate is absent, therefore 2x into y is 0 I am substituting directly. So x square by y is 0. Now what is this? This is along x-axis, right? Yes or no? So therefore this value, so numerator is 0, denominator is x square plus y square, right? So x square plus y square. Yeah. Numerator is 2x into 0, 0. Denominator is just x square. Okay. And this is limit x comma y reaching to origin 0 comma 0. Okay. So now limit x comma y reaching to origin along y-axis, along x-axis. Simplify the function. 0 by x square is 0. Now what is this value? There is no term inside, therefore answer is 0. Understood? So this is L1 now. So this is L1, first limit along first path. Next same. So by path 1 you are getting limit value is how much? 0. Okay. Next go to the path number 2. So same thing. So limit x comma y reaching to origin. Now my goal is I have to reach to origin along, choose the different paths. Now along y-axis I am choosing. Through y-axis also I can reach, like this or like this I can reach. Through negative y-axis also I can reach. Through negative x-axis also I can reach. Okay, along y-axis. Now what is that? 2 into xy upon x square plus y square, right? So now along y-axis, so any point on the y-axis look like 0 comma y. That means what? X coordinate is absent. So now apply this. So x comma y is reaching to origin along y-axis. Okay. Now 2 into x coordinate is absent, 0 into y. Y is present on y-axis. So 0 square x square plus y square. Now this will be limit x comma y reaching to origin along y-axis. What is this? 0 by y square. And if you simplify this, limit x comma y reaching to origin, along y-axis. What is this? 0. Simplify the function. Now there is no function inside, x and y terms are not there, therefore simply constant is there. Limit of constant is constant only. Now this is what? L2. Okay. Now what can you say here? Along L2 you are getting the same. So we are having same limits, right? L1 is 0 and L2 is 0. So can I say that, so limit value is same, therefore the function is limit exists for this. I cannot say why, because after all 2 parts only you have selected. Okay, along these 2 parts only you are getting same limit. If I choose 2 different parts, like for example if I choose this path and this path, you may get different limits. So therefore what I want to say is, you should take any 2 different parts. Along any 2 different parts, if the limit is same, then only limit exists along any 2 different parts. But here only 2 parts you have selected. By looking at only that particular 2 parts, I cannot say that limit exists. Understood? So You may get by another parts the limit may not be same by looking at this one. Look at by second method, I have selected y is equal to mx. That means y is equal to x path I selected, y is equal to 2x path I selected. So along these two parts we are getting different limits. Okay. See, remember one thing is final. If along any two different parts, if limit is same, then limit exists. For example, along two parts limit is same. Again, along two parts limit is different. Then I can say that limit does not exist. But best example is this one only. Look at for this particular two x and y axis, we are getting same limit. So that means x and y axis. These are two parts. But if I select y is equal to x and y is equal to 2x now, let us take these two parts. Now limit is not same. Then finally, what can I say? Along any two different parts, limit is not same. Therefore, limit does not exist. Therefore, limit does not exist. So therefore, what I want to say is here, example, same by method number 3 only. Along x-axis, you are getting limit 0. Along y-axis, you are getting limit, for example, you are getting 2. Let's say you are getting number 2. So L1 is 0, L1 is 0, and L2 is 2. Therefore, limits are not same. Now you can conclude that therefore limit does not exist. Because for this particular two paths, limit is not same, right? Limit does not exist. Limit does not exist. That's it. For example, along these two paths x-axis and y-axis, you are getting limits are 0 and 2, and you are choosing another two paths limit is same. Again, conclusion is limit does not exist because limit is not same if there exists one particular pair of paths such that limits are not equal. Then conclusion is limit does not exist. So conclusion is, don't get confused. Let me write here. If there exist two parts such that limit is not same, therefore limit does not exist. So this is a main. Limit does not exist. Okay. So this what you have done. This technique will not work out if limits are getting equal. Okay. If limits are getting equal, this technique will not work out. If limits are not equal, this technique will work out. So next one, method number 3. Okay. So limit x comma y reaching to origin. Okay. 2xy upon x square plus y square. So now what we are having is here, let us choose, this is origin. So this is origin. So in an open disk, delete a neighborhood of this disk, we have to approach. So in any of the direction you can approach. Now I am taking the parametric equations here, writing like this. So limit x comma y is reaching to origin along x is equal to r cos theta, y is equal to r sin theta as r tends to 0. Okay. Now this is 2xy upon x square plus y square. Okay. Now this is, so instead of writing limit x comma y reaching to 0, now I am writing r is tends to 0 in the next step. So x is equal to r cos theta. So 2 into r cos theta and y is equal to r sin theta. Okay. Divided by x square plus y square. What is x square? R square cos square theta. Okay. Plus r square sin square theta. R square sin square. So if you simplify this, so limit r tends to 0. R is tending to 0 means what? Radius is going to 0 means what? The circle is shrinking. If the circle is shrinking, it will reach to origin only. Our goal is to reach origin only, right? 0, 0. So this will be r square to sin theta cos theta is sin 2 theta. Sin 2 theta divided by r square common. So sin square theta plus cos square theta is 1. Sin square theta plus cos square theta. This is 1. Okay. So therefore finally you will get the limit value as, so limit r is reaching to 0. Okay. What is the integrand now? The integrand is r square. So r square is out. Okay. Only sin 2 theta I will get. So there is no, say limit is for r, there is no r term, so it will like constant sin 2 theta. Therefore answer is sin 2 theta. Again limit is depending on theta, so therefore conclusion is limit is depending on theta, depending on theta. So therefore limit does not exist. Limit does not exist. That means if we change theta value, limit also will change. Okay, it does not exist. That's it. So any of the method you take, we are getting limit does not exist. So these are the techniques. Any of the technique you can apply your wish. Okay. Problem number 5. Find the limit of this. Again use any of the technique. So now I am using this technique. So limit x comma y is reaching to origin 0 comma 0. So 2x square y upon x power 4 plus y square. Now I am choosing cleverly. Look at, again reaching to origin. Therefore I need to choose a path such that the path should reach to origin. So along, look at y is equal to mx square I am choosing. Why mx square? Why not y is equal to x? So if I choose y is equal to x, what happens here? X power 4, x square I will get. So denominator only x square I can take it. Numerator again y is equal to x. X cube is there. If I choose y is equal to mx square, substitute here. Mx square means again x power 4. So numerator, denominator is same x power 4 you are getting. And numerator, look at mx square. So x power 4. Same x power 4 terms I am getting. Therefore I can cancel out easily. So because of that reason, to cancel out, I am choosing y is equal to mx square. Now if we simplify this, so limit x comma y is reaching to origin. Along y is equal to mx square. Okay. So now 2x square, simplify this, 2x square and y is mx square. So that x power 4 is generated. And denominator also x power 4 is generated, that will be cancelled. X power 4 plus y square, that means mx square whole square. Okay. And the limit x comma y is reaching to origin along y is equal to mx square. Okay. Now this will be 2m, because x power 4 I am taking numerator, that will be cancelled out with denominator. If you want, you can write x power 4 into this, and denominator, let's take x power 4 is common, we will get 1 plus m power 4. Okay, and this 2 is out, x power 4 is out. Therefore what is the limit value now? Only 2m by 1 plus m power 4. Now look at, again limit value is depending on m. So if you change the parts, like for example if I choose y is equal to 2x square, what is the limit? 4. Yeah, instead of m we choose 2, like that. So so clearly I can write like this. So therefore limit depending on limit value depending on path, because if we change m value, then limit value will change. Limit value depending on paths. So therefore limit does not exist. Limit should not depend on path. Therefore limit does not exist. Limit does not exist. If you want more elaborately this one, so that is along y is equals to, let us take x square only, just x square. That means what? Indirectly I am choosing m is equal to 1, right? Look at the bulk of paths, set of paths. Y is equal to mx square is a set of paths. Instead of m I am choosing 1. So then what is the limit value now? So limit value will be 2 by 1 plus 1 power 4. That means you will get 1 is the limit. Okay. Now along second path, along y is equal to 2x square you take. That means m is equal to 2 I am taking. Look at on these two parts will go to origin. Okay. Now m is to substitute 2 into 2. So 2 into 2 divided by 1 plus 2 to the power of 4. So now you will get 4 by 17 is the limit. Look at two different limits you are getting along two different paths, therefore limit does not exist. So therefore conclusion is so therefore along two different paths. You can conclude like this also, or you can stop till this only, no problem. Limit is depending on path, therefore limit does not exist. Along two different paths or two distinct paths, whatever. Along two different paths, we have two different limits. Two different limits. Therefore limit does not exist. Two different limits. Two different limits. So therefore limit does not exist. Does not exist. That's it. Okay. This one. Next, problem number 6. Look at this. I will give the hint, you try this. Again same, it is reaching to origin. So limit x comma y is reaching to origin. Okay. Now you need to choose cleverly the path so that the similar terms will be cancelled out from numerator and denominator. X square plus y square. Okay. Yes, let us choose. If I choose along the path, so along. So if I choose y is equal to mx, x square I am getting same terms, right? Denominator same terms. So along y is equal to mx you choose. Same power you should get. X power should be same. Like that, such a kind of path you choose. That is better. Okay. To avoid some difficulties. That's it. Or you can choose any of the path your wish. The calculation becomes lengthy. That's it. So x comma y is reaching to origin along the path y is equal to mx. Y is equal to mx. Right. Now 4 into x into mx whole square divided by x square plus mx whole square. So if you simplify this, so limit x comma y is reaching to origin, okay, along y is equal to mx, right? So numerator will be 4x cube m square, and denominator x square is out, 1 plus m square. Okay, now x square is out, so here x square and here 1x will remain. So finally what will remain? So limit x comma y is reaching to origin. So this is reaching to origin along the path y is equal to mx. Along y is equal to mx. Yeah. So here 4 into x into m square and divided by 1 plus m square. Okay. Now 4 into m square divided by 1 plus m square is out because this is irrespective of limit. There is no x terms. But here limit x comma y is reaching to origin of only x will remain, right? Look at only x term. So what is this? 0. So 0 into this is 0. That's it. 0 into this constant is 0. So now whatever the path you choose, y is equal to 2x, y is equal to 3x, whatever you choose, definitely numerator 1x will remain. Limit x tends to 0, that value is 0. So along two different paths you are getting only same limit. So therefore conclusion is, so therefore along any two different paths, we have same limit. So therefore limit exists and limit value is 0 and limit value is 0. That's it. So this is the final conclusion. Let us choose two different parts. So I am choosing now. So y is equal to mx, right? So let us choose y is equal to x. If you choose y is equal to x, what will get 4 into x square, right? Numerator. Instead of y square, I am writing x square divided by x square plus x square. Now what will get 4x cube by 2x square. Now that means what 2x you will get, right? Now limit x comma y reaching to 0, 0, you will get this one is 0. You are getting 0. Now you choose y is equal to 2x. What is the integral function? 4x into 2x. 2x whole square. Isn't it? Divided by x square plus y square, right? X square plus y square is 2x whole square. So what will get here? And this will be, so 4 16x cube. 16x cube divided by 5x square 5x square. What will you get again? Look at x will remains in the numerator. Again 0 you are getting. Like that. So you choose any two different parts, the limit value 0 you will get. Therefore, along any two different parts we have same limit. Therefore, limit exists, which is, for example, if limit value is some m values like this, only 4m square by 1 plus m square you are getting, then limit is depending on m value. Therefore, limit does not exist. That's it. Next continuation problem number 7. Find the limit of this x comma y is reaching to 0 comma 1. Okay, so now limit x comma y is reaching to 0 comma 1, y minus 1 into tan square x divided by x square into y square minus 1. See, blindly don't proceed directly by path limits. If you are getting 0 by 0 or infinity by infinity, then only we can go for path limits or simplifying the function. Substitute the limit 0 comma 1. If x is 0, tan 0 0 and y is 1 minus 1 0. So numerator is 0 divided by denominator x value is 0 and y value is 1 minus 1 0. So 0. I am getting 0 by 0 form. Then go to either path limits or simplifying the function. Now look at this problem. Y minus 1 here, y square minus 1, I can write y plus 1 into y minus 1, so that y minus 1 will be cancelled out. So it seems to be simplifying kind of. Let us go for simplifying the function, because by looking at the function I am deciding that. So now it is y minus 1 numerator into tan square x divided by x square into y square minus 1, I can write y minus 1 into y plus 1. A square minus b square will be a plus b into a minus b. Okay. Now cancel out the similar terms here. Y minus 1 is out with y minus 1 in the denominator. So now what you will get? So limit x comma y is reaching to origin. X comma y is reaching to origin. What is remaining? Tan square x by x square into y plus 1. Now we apply limit tan square 0 0 by again 0 I am getting. So again 0 by 0 form. Again simplifying, will you get? No simplification, because there are no similar terms kind of. So this I can write. So limit x comma y is reaching to origin, because already you are cancelling out the terms. That means first method you are applying. That means simplifying the terms. So therefore by first method only need to approach. So this I can write tan square x divided by x square, I am writing one function, into 1 by y plus 1. By quotient rule, theorem number 1 in the last lecture, not quotient rule, product rule. So what is that product rule? Let me recall. So limit x comma y is reaching to x naught y naught. Just recall product rule. Why not? F of x comma y into g of x comma y is what? L into m, right? Where what is L? L is limit x comma y reaching to x naught y naught. F of x comma y value is L. Next, what is m value? Limit x comma y reaching to x naught y naught. G of x comma y value is m. So by product rule, just refer theorem number 1, product rule. So by using this rule, so therefore limit can be applied to, let us take this is f of x and this is g of y, two functions separately. So then apply limit separately for these two functions. Okay. So this is 1, right, reaching to 0, 1, and this is also 0, 1. Okay. Yeah, let us apply the limits to separately for this function and this function. Then this will be, so limit x comma y is reaching to 0, 1, right, tan square x divided by x square, right, this one, and into limit x comma y reaching to 0, 1 of 1 by y plus 1. This is second function, like by using product rule. So now this will be, yeah, so limit, substitute the limits, what you will get, x is 0 and y is 1. If you substitute x is 0, 0 by 0 form you will get. Now you will apply L'Hospital rule here. Why? Because functions of single variable you are having. Okay, this function of single variable only. Now you can apply L'Hospital rule. By L'Hospital rule, tan square x derivative 2 into tan x, okay, and tan x derivative secant square x by chain rule. First 2 will come down, 2 into tan x. Tan x derivative is secant square x divided by x square derivative is 2x. Separate differentiation. Here I applied L'Hospital rule because it is a function of single variable. Okay. Now again same story, limit x comma y reaching to 0, 1. What about this one? You apply directly limit for this. What will get? So this will be direct limit value is x is 0 value and y value should be 1. Substitute y is 1. 1 by 1 plus 1. There is no extra. And this one, so again you substitute x is 0, y is 1. Only x terms, x is 0. Tan 0, 0. Again 0 by 0 form you are getting. Okay. So again 0 by 0. So therefore again one more time L'Hospital rule. What do we get? So limit x comma y is reaching to 0, 1, right? UV method, isn't it? So first tan x derivative secant square x into secant square x as it is. Okay, isn't it? Next plus tan x as it is, secant square derivative, so 2 into secant x, and secant x derivative secant x into tan x, secant x into tan x. Hope you are perfect about the derivatives. This is UV method for numerator, and denominator derivative x derivative is 1. Okay, okay, and plus 1 by 2, sorry, into 1 by 2. The second function limit value is 1 by 2. This one 1 by 1 plus 1. Okay, look at once again. First tan x derivative is secant square x and secant square x as it is, plus, and tan x first as it is, secant square x derivative 2 into secant x, 2 into secant x, and secant x derivative secant x into tan x, like that. Now you apply the limit x is 0 and y is 1. Only x terms, x is 0. So only numerator I am getting, denominator is 1. So substituting the numerator, x is 0. Secant square 0 is 0. Secant square 0 is 1. So 1 into 1, secant square 0 is 1, plus tan 0, 0 into 2 into secant 0 is 1, secant 0 is 1, and tan 0 is 0, divided by 1 into 1 by 2. And simplify this, 1 plus 1 into 1 is 1 and this is 0. 1 plus 0 is 1. So 1 by 1 into 1 by 2. Answer is 1 by 2. So therefore limit value is 1. Problem number 8. Find the limit of this 3 variable function. Actually it is not required. Let us focus on only functions of 2 variables. Okay. So but for simplicity, so direct substitution problems I am doing. X comma y comma z is reaching to 1, 0, 2. It means here x is reaching to 1. Okay, x is reaching to 1 and z is reaching to 2 here. Okay, z is reaching to 2 and y, this y is reaching to 0. y is raised to 0, like this. Okay, and the function is x plus 2y minus z, 2y minus z minus z upon x square into y plus z, y plus z square. Now substitute the limit. Wherever x there is 1, wherever y there is 0, wherever z there is 2. Okay, let us substitute 1 plus 2 into 0, 2 into 0 minus 2 divided by x square. That means 1 square, y value 0 plus z square, z value is 2, so 2 square. So answer is 1 minus 2, so minus 1 divided by 4. So minus 1 by 4 is the limit value. So don't worry about these 3 variable functions. Let us concentrate only 2 variable. So that is enough for your standard. Okay. Next one, continuity, the simple one. A function f of x comma y, function of 2 variable, is said to be continuous at the point x naught y naught. The point name is p. So this is continuous at the point x naught y naught if the condition is, first one, f is defined at that point x naught y naught. That means indirectly f of x naught y naught is a finite number. Okay, that should be defined first. The second point is limit value should exist. Limit x comma y reaching to x naught y naught, f of x comma y should exist. Third point, these two should be equal. Each one, f of x naught y naught should be equal to this limit value. That is the third point. So limit value is equal to f of x naught y naught. First, f of x naught y naught should be finite. Direct substitution. Function is given to you, just substitute x naught y naught value and you will get one value that should be finite value. And that value should be equal to this limit value. That is the third point. Then I can say that the function is continuous at x naught y naught. Next, removable discontinuity. If f of x naught y naught is defined like this, that means it is finite number. Like this, f of x naught y naught is finite. And limit value is L. But previously, what is the limit value? Limit value exists and that should be equal to f of x naught y naught, I said. But it is not f of x naught y naught, it is just L. So limit value L and f of x naught y naught is exist. Then if L is not equal to f of x naught y naught, that means this L value is not equal to f of x naught y naught. Here, look at, this is L value, right? This second point, look at the continuity definition. Second point, this is L value. Here L value is equal to f of x naught y naught. Then it is continuous. If L value is not equal to f of x naught y naught, then the point x naught y naught is said to be point of removable discontinuity. It is discontinuity point only, but particular one name, that is removable discontinuity. That means you can redefine the function f of x comma y such that the function may be continuous, like that. I will explain this in the problems, don't worry. Now look at, show that this function is discontinuous at origin and continuous other than origin. Okay. Now look at. So based on definition, so it is a proof because we need to show that, right? Show that the function is continuous at origin. So by definition, so therefore what is x naught y naught here? X naught y naught is 0, 0. Okay. Let me make it very clear. So this is x naught y naught. So what is f of x naught y naught now? F of x naught y naught is nothing but f of 0, 0. What is f of 0, 0? By definition, look at, if x is 0, y is 0, function value is how much? 0. This is by direct substitution. I am not finding limit value, remember. So therefore, first point is satisfied. First point is f of x naught y naught, that is f of 0, 0, is defined. Why it is defined? Because 0 is a finite number. Is defined. Since this is finite number. Okay, first point is satisfied. Next, what is second point? I need to compute the limit. Okay, so limit x comma y. So x comma y is reaching to x naught y naught. I want this value. So this value should required. So therefore this is x comma y. So this value will be, so limit x comma y is reaching to origin 0, 0, origin 0, 0. And what is f of x comma y? Twicely x into y upon x square plus y square. Again go to the path limits. Same story, and this problem already I did. Look at first problem. So look at first problem. Not first problem, I think which one it is? Fourth, I think. Look at previous problems. Previous problem number 4, I think. Check once. Problem number 4. Okay. So what I got, or y is equal to mx path you take. So limit does not exist. This. Choose y is equal to mx path. So limit does not exist. So actually this limit should exist and this value should be equal to 0, right? So third point. So what is the third point now? So third point is limit x comma y is reaching to origin of f of x comma y, and this value is not equals to f of x naught y naught, right? What is f of x naught y naught? This value is 0. This value is 0, but this value is not equal to 0, right? It is not satisfied. Therefore, the point conclusion. So therefore, 0 comma 0 is discontinuity point. Discontinuity point. That's it. Okay, that's what I need to prove. So it is discontinuous at origin I need to prove. Next, continuous at any other point other than 0, other than origin I need to prove. So you can comment like this also, or f of x comma y is discontinuous is discontinuous at 0 comma 0. Next one, I need to prove that it is continuous other than origin, right? So now, so therefore, let x naught y naught, I need to choose x naught y naught belongs to r square minus origin. So from r square, this point I am removing. That means what, other than origin. So I am choosing a point from r square minus 0 comma 0. That means other than origin I am choosing. So therefore at this point function should be continuous. So what is the first point? F of x naught y naught should be well defined, right? So f of x naught y naught. Now what is f of x naught y naught here? The function f of x comma y is 2xy divided by x square plus y square. X square plus y square. Okay. So then f of x naught y naught means direct substitution is required here. So that means wherever xy is there. So what is f of x naught y naught now? Wherever x naught, wherever x, there you substitute x naught. Wherever y, there you substitute y naught. So what is f of x naught y naught value? 2x naught y naught divided by x naught square plus y naught square. That's what I'm writing here. So 2x naught square y naught square, sorry, 2x naught y naught divided by, so 2x naught y naught divided by x naught square plus y naught square. Is it infinity? It's not infinity. Look at x naught y naught is x naught square plus y naught square. This one also not equal to 0. If this is equal to 0, denominator is equal to 0, then something by 0 is infinity, right? So therefore there is no chance of it is infinity. So therefore conclusion, 2x naught y naught divided by x naught square plus y naught square is finite. So this is finite. Okay, so therefore this is finite. Okay, that means it is well defined. So then second point is I want limit value, right? So limit x comma y reaching to x naught y naught what is f of x comma y? So 2 xy divided by x square plus y square, and now this is, so this value we need to compute. So again same story. So what is meant by this? X is reaching to x naught and y is reaching to y naught. So therefore this function of two variables having two techniques. One is by direct substitution of limits. If we are getting 0 by 0 or infinity by infinity form, then I will go to path limits. Okay, or simplifying the function. So there are two techniques over there. But how to decide is it 0 by 0 or infinity by infinity? First of all, there is no chance of, can it be 0? X naught into y naught. See, look at here, look at this. Yeah, I want to be more elaborate this. X naught, see, if x naught y naught is not equal to 0 comma 0, does it not equal to 0? It can be equal to 0 also, right? It can be equal to 0. Why? Because you choose the point. If x naught y naught, the point is 1 comma 0, for example. So 1 comma 0. 1 comma 0 means what? Indirectly, it is not equal to origin, right? It is not equal to origin only. So if x naught y naught is 1 comma 0, then what is x naught into y naught value? It can be 0. 1 into 0, right? X naught is 1, y naught is 0. So it can be 0. Not equal to 0 or equal to 0. Or equal to 0. So numerator not equal to 0 or equal to 0. But denominator never equal to 0. It is always not equal to 0. Whatever the point which is not equal to origin you choose, denominator is never 0. Once denominator is never 0, then this value is finite value. If denominator is equal to 0, then sometimes finite by 0 is infinity. It is a chance of infinity here. So therefore this value is finite, therefore it is well defined. So it is finite, so therefore it is defined. It is defined. F of x naught y naught is defined. So therefore here I can write, so therefore f of x naught y naught is defined. X naught y naught is defined. Is defined. So nothing is difficult, just you focus. That's it, nothing else. And here now same kind of story. So here, can you get, there is no chance of 0 by 0, what I want to tell. Actually, numerator, there is a chance of numerator 0, but there is no chance of denominator 0. Therefore, 0 by 0 chance cannot occur. So this cannot occur. What about infinity by infinity? Can you choose infinity by infinity? First of all, there is no infinity in real number system, right? Because what is R? R is nothing but minus infinity to plus infinity, that's it. R is identical equal to minus infinity plus infinity. Infinity not included, it is open interval, right? Except minus infinity plus infinity, the interior point should belongs to R. So therefore there is no infinity and minus infinity in the domain, therefore there is no chance of numerator is infinity. No chance of numerator is infinity. What about denominator? Denominator also there is no chance of infinity. Therefore this chance never occurs. So 0 by 0, infinity by infinity never occur for this limit. Then what to do? Direct substitution is required. Direct substitution. That means wherever x there x naught you substitute. Wherever y there y naught you substitute. Therefore you will get 2 x naught y naught divided by x naught square and y naught square. Okay. So let me write. So therefore final conclusion is, so therefore now what is the third one? Both should equal, right? So limit x comma y reaching to x naught y naught of the function f of x comma y, and this should be equals to f of x naught y naught. Are they equal? Let us verify. By looking at first and second point, what is this limit value? Limit value is 2 x naught y naught divided by x naught square plus y naught square. And does it equal to f of x naught? What is f of x naught y naught? Look at f of x naught y naught is, by first point it is 2 x naught y naught divided by x naught square plus y naught square. Look at satisfied. So it is satisfied. Third condition is satisfied. All three conditions satisfied. So therefore conclusion is, so therefore f of x comma y is continuous at all the points x naught y naught other than origin, because at origin it is discontinuous other than origin. Or you can comment like this, or f of x comma y is continuous, okay, is continuous at x naught y naught, which is belongs to r square minus, I am removing the point origin. So in this domain it is continuous, except origin it is continuous. So this is the final comment of this. Okay. Next one. Look at this problem number 2 in this. Verify the continuity of the function f of x comma y this at the origin only. So at origin, what is the continuity of this function? Take it exercise. Once you try, if not, I will explain in the next class. But try with your own. Same story, but here it has to reach to 0. See, if you substitute directly 0 comma 0, what will you get? 0 by 0, you will get tan 0 0. So therefore, you can go to the either path limits or simplifying the function. So here there are no similar terms, therefore you cannot simplify the function. So compulsory to go to the path limits. So choose the proper path. Okay, then find the limits and verify whether it is continuous or not at origin. Okay, take it exercise once you try with your own. And with this, I will stop.